All right, very quickly reviewing everything on surface area and volume. You know the formula is 4 pi r squared. Plug in the r, which in this case is 4. That one was like 201.1, I think. Over here, we're going to say 4.5 squared. Where does that 4.5 come from?
Half of 9.
I got to do 9 divided by 2 to give me the radius. And that one was 254.5. All right. Then if it gives me the surface area, I'm going to plug that number in for the S. What's my next step? So I'm going to divide by 4 pi. What is this number?
46.3.
So I have 46.3 equals r squared. Square root that. Is that 6.8? Over here it says find diameter. I'm still going to start the same way. I'm going to divide by 4 pi. What is that part? 25.4. When I square root 25.4, I basically just get 5. But again, what is that? That's radius. I know that the diameter is 2 times the radius. So 2 times 5, my answer would be 10. If it says solve for a hemisphere, what do we do? Somebody. If we say solve for a hemisphere, what do we do?
Plug the 7 in for r.
Do everything the same and solve for the whole thing. So this whole thing would be like 615.8. But what is this the answer to?
The surface area.
That's the surface area for the whole sphere. A hemisphere is how much of one? So I'm going to take that 615.8 and divide by 2 to get the hemisphere answer. If it says, here's the circumference, find the surface area. I know circumference is 2 pi r. Make sure you notice whether or not it has the pi in there. So in this case, C is 12 pi equals 2 pi r. Divided by 2 pi, you get R6. Well, now what?
You gotta find surface area.
So surface area is 4 pi r squared. 4 pi 6 squared, plug in the 6 from the radius we just found, and the answer there?
452.4.
All right. Then we go to volume of the sphere. The only difference is we change that formula to 4/3 pi r cubed. We're still plugging in the radius, whatever it is. All right. If it gives me the volume and then says find the radius or the diameter, I'm going to plug that number in for V. And then what? Divide by 4/3 pi, and we're going to type it in the calculator just like that, a fraction inside of another fraction. And what do I get right here?
460.1.
So I get 460.1 equals r cubed, but what do I have to do on this one now? Cube root. Remember how to get the cube root on the calculator? Math 4. Hit math 4 and it'll pop up the cube root. Type in your number. 7.7. Alright. This one says, here's the volume, find the diameter and the circumference. Well, I've still got to find the radius like I just did on the previous slide. I'm going to divide by 4/3 pi. Divide by 4/3 pi. What is that number?
214.
So I get 214 equals r to the third. Do the math 4 button. Basically get 6, it's like 5.98. So when you round it up to 6. So there's my radius. I know that diameter is 2 times radius. So diameter is 12. So there's 1 part, 2 parts. Circumference is 2 pi r. 2 pi 6. 37.7. All right, this last part here, you can plug in the numbers and work everything out. When we did the numbers, plugging everything in, we got like 113.1 both times. and then 452.4 and 90, what's this one? 904.8? Double check that one
That's
for me.
right, 904.8.
Okay. All right. So what we're trying to do is compare how much bigger the second one is to the first one. Well, you can do all the numbers and then say, well, second one divided by the first one. If I do this one divided by that first one, what do I get? The 452.4 divided by 113.1.
4.
So that would be 4 times bigger. And do the same thing for the volume. 904.8 divided by the volume over here, 113.1.
8.
Should be 8. But we can get to these answers, or these answers down here, without doing all that work plugging in numbers. The way to do it is this. Take the second radius and divide it by the first radius. So 6 divided by 3 is 2. Right? Then you take this radius and say, well, or not radius, this number and say, well, that's how much bigger the second one is. It's 2 times bigger radius-wise. Well, in every area problem we ever do, what do we have in there?
Squared.
A squared. So if I do 2 squared, what is 2 squared?
4.
That tells you how much bigger the surface area is going to be. What do we do on every volume problem ever? You cube something. It's something cubed at the end. Well, what is 2 cubed?
8.
So that's all you got to do to figure out how much bigger the surface area and volume of one sphere is compared to the other one. Check the radius part, second radius divided by the first radius, and then take that number and square it for the surface area, and then cube it for the volume. Alright, so if I'm looking at this one, first thing I'm going to do is take the second radius and say, okay, well, 12 divided by 4 means 3 is the number I'm working with. That's how much bigger the second radius is than the first. Well, what is 3 squared? 3 squared?
9.
So that means this one is 9 times bigger. Remember, area is squared. Then I'm going to go back to that 3 and say 3 cubed is 27 times bigger for the volume.
I did.
All right. Any questions or problems on that?
I did that first time too.
All right. So look at this last one. Again, what's happening to the radius here? It's getting smaller, which means I'm dealing with a smaller sphere the second time. You do the second divided by the first. If it's a fraction, I would go ahead and simplify it down if possible. So I'm going to deal with 1/2. Well, what is 1/2 squared?
1/4.
So this is 1/4 as big. And then 1/2 cubed would be 1/8 as big.